Thank you very much for inviting manufacturing today. You can take us to the journey, till date. It will be very important for the audience to know about the, Revalyu.
So the journey to date started back in approximately 2005, 2006, when we recognized as a company the need to be able to recycle plastic bottles more efficiently and cleaner. So what did that mean? It meant that at the time there were a large number of companies in the world which were recycling plastic bottles, and in particular India was one of the leaders in that sector. India had traditionally taken mechanical recycling, taken a plastic bottle and produced what is called staple fiber for the textile industry. However, as the industry developed further and further, there was a higher need and a higher demand for material that had higher quality. In order to get that higher quality, you needed next generation technology or new technology that could effectively remove more of the impurities, provide a product that had much higher consistency, that could tolerate and give better dyeability to the product, higher tenacity, and also allow the growth of the sector. In order to do that, Revalyu identified glycolysis as the correct chemical recycling technology in order to be able to achieve this. We started with our glycolysis technology and developed that back in 2007 and built and brought that technology here to India and retrofitted that technology to a company which was based in Nashik. That company in Nashik used to traditionally make virgin grade material from oil and gas. So part of the benefit of this technology is it can be quite easily retrofitted to existing plants that are no longer profitable because they're not big enough to compete against the giants in the oil and gas sector. The story since then has been a gradual migration and expansion with the team, so that over the last now 15 years, the plant in Nashik has been producing at 40 tons per day, every day, which is approximately 4.5 million plastic bottles recycled, and selling that to customers all over the world, converting it predominantly into yarn and for the textile chip market.
Revalyu PET recycle facility, especially in Nashik, is now the world's largest chemical recycling site. What inspires this significant expansion, and what are your primary goals for this facility?
So as we always developed the technology, we always had a desire to expand. As part of that expansion, we went to raise funding and capital, and we had a meeting with a big investor, and maybe my colleague here can tell us about that investor and the help that that investor has given us to expand today.
Yeah, so effectively, our plan was to find a technology that in a clean way makes PET recycling continuously possible. Meaning the downside of mechanical recycling, which are impurities and a certain limitation on the recycling cycles, should ideally be rectified by a technology. That was something the investor was looking for. And at that point in time, we found Revalyu to be one of the most promising technologies by its glycolysis technology to recycle PET always back into PET. So you can take 100% post-consumer PET, and through the process you can put it back into what is again a 100% comparable to virgin PET, which can be used in any kind of PET application that you also conventional PET use for, like for example bottles, packaging, or textiles, of course.
So with an investment of over 100 million for the new recycling lines, how does Revalyu evaluate the return on investment in sustainability projects?
Investment returns for this project we engage around in a period of about 4 to 5 years at a rate of about 70 to 80%.
Can share how the increased production capability align with Revalu's long-term strategic goal and vision for global plastic recycling?
So the first stage for us was going from effectively 40 tons per day to a line, or each line now operates at 120 tons per day. So what we have announced today is the launch of that second line of 120 tons per day, which recycles effectively approximately 15 million plastic bottles every day now. So that is in the first stage. Makrand and the team are also now developing the next plant, which is Nashik 3, which will be up and running approximately Q3 next year. And that will then complete this Nashik site to be a total capacity of 280 tons per day, i.e. 35 million plastic bottles recycling. Beyond that, we are now working with our investors as a team and looking elsewhere. We've made some announcements publicly, but some of them we're also keeping confidential. And
Yeah, so the next step of expansion is the US. We have found out after a screening of different countries to expand to that the US is the most promising country in terms of further investment. There is a huge availability of PET waste that is currently not recycled at all. And this is a treasure which you can use to make new PET again out of it. Effectively, that what we will do is to copy the plant which we have built here in Statesboro. So the capacity of in total 120 tons per day plus 120 tons per day will be also erected in Statesboro. And that is the immediate next plan for expansion. Beyond that, we are trying and we are enforcing to reach the goal of 1,000 tons per day by 2030.
How does the use of advanced automation and technologies enhance the efficiency, scalability, and especially the recycling processes?
Recycling process, because we developed the process for over a decade, and we are leveraging all the know-how, all the learnings made over a long period. So there are improvements in many areas, including the metallurgy of the plant, including the processing techniques, how the way material is moved. So because of that, a lot of changes are happening. Like in the earlier plant, we were using bags to feed raw material. There will be silos, there will be a system to take it directly to the plant. So practically, the product is becoming an untouched product. And even at the finished product end, bags will be filled with a auto bagging system, and then there is a robotic warehouse. So practically, the product will be untouched by humans since it comes to the plant and till it leaves the plant. So it's all the process is taking place, and this is very important, particularly where the products is being provided for applications where food is concerned. So wherever food packaging is concerned, it becomes very important on these aspects. Now we are expanding it to a volume of over 3 times. So that brings in a lot of automation in order to control the process. Already the process provided a very high advantage in terms of controlling the properties. But apart from controlling the properties, now we are controlling the process with a lot of automation. So there is a control system which is controlled practically from one room. You can control the entire plant. That process is in place, and because of that, the chances of having any deviation in process or in product are minimized. So that is how we are doing automations and process improvements.
one of the beauty about chemical recycling is consistency of product. Because everything is controlled and automated, whatever feedstock you input, your feedstock can vary, but your output is consistent. So from a customer's perspective, compared to traditional methods, he or she knows that whatever they get in November 2024 will be exactly the same as what they get in January 2025. The chemical composition of the material will be the same. The other benefit, of course, with chemical compared to traditional methods is in scalability. The ability to go from 40 tons to 120 tons per day, as we've correctly already proved, was not difficult. It's a matter of scaling the vessels, etc. And your cost is not linearly scaled. Your cost dramatically reduces. So these are the two significant advantages of chemical recycling. As Jan mentioned earlier on, the removal of the impurity to a much clearer thing, the automation with scale, and the cost reduction.
With the capacity to recycle over 35 million plastic bottles per day, what environmental impact does Revalyu aim to achieve both regionally in India as well as globally?
Our carbon footprint is actually one of the best as polyester, and maybe Martin, you can talk about some of our environment.
There is a lot of data available how it helps us. How many, if we do not recycle, we'll take that much crude oil to make those bottles or those yarns. So that savings are there, or you can even calculate in terms of the carbon footprint, because now it is proven carbon footprint is directly impacting your ozone layers, which is impacting the temperatures of the earth and which is impacting the environment. So those aspects are there.
And I believe, I can't remember the exact number, but we are approximately, is it 91 or 97% less energy and 86% less water?
Yeah, and less to what is then always the question. So compared to conventional PET production, we have a CO2 footprint that is 90% roughly plus less. And compared to the water used to conventional production, it is more than 70% less. So those are, I think, the major credentials which come with our chemical plant. In addition to that, I think it is also important to mention there are different chemical processes out there and also different glycolysis processes. And even amongst other glycolysis processes, we have a really good benchmark insofar as we have a low temperature and nearly atmospheric pressure process, which allows us to have or reach these low processing costs.
Beyond environmental benefit, are there social or community-oriented initiatives connected to your operation in Nashik? And how do they contribute to revaluation?
So we are part of the community, local community. We are based in this village around here. So the first thing what we started right from the beginning was to give priority to the people of Avankhed and surrounding villages for employment. So that was one of the most important philosophy of the company. Two, then we started, as we started progressing and making operations viable, we started helping the community in various ways. So recently we have helped the local community to build a community hall in this village. And with that community hall, now they can have meetings, programs, and the school is adjacent to it. The school had no place to conduct any programs. So that was built from dual purpose to help the Gram Panchayat to have their programs as well as for the school. That was one. Two, we have also helped them for building some of the roads in the village. Then we are also going to build one longer road in the village which they are not able to build right now in the Gram Panchayat problems. And in the longer term, we will also help them for some of the things like ambulance in the village. So that is also on the cards. So we are helping that village to develop wherever they need these kind of things. We are helping. Plus, we are also conducting some other programs for them. Like in the past, we took help from one of our customers to encourage for sports. So we took that help and brought some experts from that brand to the village and school, and they were provided some of the materials like the basketballs or the volleyball nets, all those kind of things that the students were trained to play those sports. So that kind of activities are also being done. We conducted some of the initiatives to explain people what are government initiatives, and that is a very interesting thing. Government comes out with not many initiatives like Ayushman Bharat, and many people don't know how to enroll for those things. So we help them to enroll for those things. We create awareness for that, and now that program we will implement in few more villages. So that is how we are trying to help the communities around us.
The site now produces 280 tons of high-grade PET polymers, and our PET chips daily. What sectors are showing the highest demand for this recycling material, and how do you see the demand evolving?
Yeah. So the site is designed to operate at 280 tons per day. Today we're operating at 160 tons per day. And the next 120 tons per day will be operational by Q3 2025. One of the beauties about the Revalyu technology and the Revalyu products is that we are kind of agnostic as to what our customers use the product for in terms of their end application. In other words, we supply essentially the raw material of recycled polyester. How they want to use that polyester in their material is up to them. To date, the answer to your question is the vast majority of our customers are using it in the textile sector. And they're using it to make clothing, very much like the t-shirt I'm wearing, which is made from 100% plastic bottles using our yarn. But they are also able to take that and implement it, as Jan was mentioning, into other sectors: packaging, bottles, automotive, wind turbine blades. Wherever you have polyester, you could effectively take the Revalyu product and replace normal polyester or made from oil and gas with sustainable polyester made from Revalyu.
Anything specially in automotive you wanted to touch base on?
So we are doing in two ways. Some of the products are in textiles. So for the linings and other applications, seat covers. So that is, so some of our customers are producing that. And additionally, we are also working with some companies to produce some of the engineering plastics. So that is a combination of polyester and some other materials. So that will be a composite material. So that is also one area where we can help the companies to produce those kind of things. With the normal recycling, that is a challenge because you have to engineer the properties. You have to create a material with some different properties for that. So that we are able to do. And for that, we are working with few engineering companies right now to develop those products. So that is one area that is how we will be growing quite big in automotives in coming years.
When you take a look at it just from another angle, the current goals that the big companies set themselves for sustainability, as you can see. So we would like to have 25% recycled content by 2030, or we would like to have 35% recycled content until 2030. That is driving the demand question that you have asked, right? So as Vivek outlined, our product can be applied everywhere. We are flexible in terms of which customer we serve. And the demand is dictated by the own sustainability, let's say, initiatives the customer has. And we can help our customer to reach his sustainability goals. And that is, I think, an important message also for the customers, because now there is high quality rPET available for the customers.
What challenges and opportunity do you foresee in meeting the demands for recycled PET material, in particular industry moving towards sustainability sourcing?
I think one of the big challenges will come in particular when it comes to quality. So that's what we find currently in the market, and that is also the reason why there is this value in our company, is you find a lot of material that is downgraded. So you recycle a bottle, but the result of rPET can only be used, for example, for strappings or go into downgraded materials. That is not the intention of recycling. Recycling means you're using the material effectively for something, again, which it was supposed to be before. So the idea is to put it back into something which has a good value, at least the value that you had before, to reach circularity. That is a challenge companies currently face with mechanical rPET. And due to our purity and quality of the product, we are able to provide the customer the high quality he needs to reach his quality goals.
If you can throw some light on the R&D, as a budget what you have spent, which you do, and how does it help you stay competitive in India as its global market?
So as we have expanded our production capacity and as we've expanded our team, we've also grown our R&D sector. So today we have approximately 25 to 30 people focused exclusively on R&D. That's what they do. The R&D is focused really in two broad areas. One is getting the customer applications and working, as Makran has said, with the engineering companies to take the product into new customer applications. The second place on the development is also looking at bringing our costs down and our operating costs down as we continue to scale up. So making things more efficient at the plant. And then the final plan is also looking at the feedstock input side. So in addition to taking in plastic bottles, where we have and have been looking for more than a decade at also taking other polyester feedstock and polyester waste. So at the end of the day, the Revalyu technology is almost like an engine. It's an engine where you can put in polyester waste, it cleans the polyester and processes it using glycolysis as the chemical engine, and then it produces a high-grade, high-quality material, which is polyester-based that can be used to replace conventional.
With an investment of 100 million, how does Revalyu plan to ensure a sustainability financial return while staying competitive in the global recycling industry?
So today, the demand for the product is very high. Actually, it's quite interesting that in the company today, we literally have one sales guy full-time. And the reason for that is the demand from the customers at present exceeds the supply in the market. So to date, really, the return is based on the demand, which makes it easy for us to sell. So as long as we can make more product, the returns are there.
From Nashik 1 to Nashik 2, if you can share some strategies, especially on the maintenance, preventive, predictive maintenance, how it is helping learning from one to the second one.
As you correctly said, the whole concept of maintenance has undergone a sea change. From preventive maintenance, it is becoming a predictive maintenance. Practically, the Nashik 2 is a repeat of Nashik 1. Most of the systems are the same. There are some changes in the utilities with new techniques coming in. But since that know-how and how those utilities behave during the production process, that knowledge base is there, some softwares to enter into a era where now we are going into a predictive maintenance method. And that is going to save a lot on cost. Even with preventive maintenance, you really cannot reduce some of the breakdowns. So those breakdowns and all those things related with the sudden shutdowns of the plant, they are time fast.
I think one important point to mention is in particular with respect to maintenance that the new site has 3 independent trains at the beginning which serve, so to say, the complete production volume, which means that what Makaran has described, which was necessary at Nashik 1 to shut down at certain times for maintenance, is no longer required. And that is also what operational maintenance means. We can have the whole plant running while doing maintenance on 2 other trains running. And the one train can be maintenance. And that is one of the big advantages, I think, when you directly compare Nashik 1 to Nashik 2.
I think the other thing that might be helpful for you to know, actually, although this is a young company, and although the technology has been developed here, and we've kept a very low profile as a group, as Makran said, this has been operating for more than 10 years, and it's been expanding. And from that perspective, the technology is extremely steady and sound. At the time the investors were doing due diligence on us, one of their concerns was the stability of the operations. We ran the company for a total of 700 days without shutdown, without a single shutdown, without any maintenance, to prove the stability of the process. So this process is really stable. It does benefit for sure from maintenance, but it's not something which is up and down like here. It is a 24/7, 365-day operating chemical plant.
Maybe a last one, what's next?
At this stage, for us as a company, we embarked upon this program really to try and make a fundamental difference in plastic recycling. It was always a recognized, back in 2006, 2007, this issue of plastic. And so we went out of our way to develop this technology, which we truly believed at that time could recycle plastic again and again and again without a deterioration in the quality. That has been proved. So we've proved that we could do that on the technology front. By 2018, we proved we could make a product that was equivalent to virgin material at a cost that is equivalent to virgin material in production. We've now proved that we can expand it and grow it and scale it. The next step for us now as a group is to find the right partners in the world to take this. Because although we talk about 280 tons and 35 million plastic bottles, the world generates 700 billion bottles a year in waste. And 35 million might sound a lot when you and I talk across the table, but when you look at the global problem, it's far bigger. So you need many, many, many manufacturing plants. And this technology can only scale now, not with us, with just in our hands. It needs to scale with partnerships globally. And that's the next real big focus.
Yeah, for us at Nashik, India level, obviously we want to make a better product with lower and lower cost. That's our target at India level. We want to reduce the cost, reduce the carbon footprint, make it industrial, so that we can replicate it in other states of India.
Thank you very much. It's really nice talking and interacting and learning.
Thank you very much for
Thank
your
you.
occasion.
Thank you for your precious time as well. It's a long way to come. We appreciate it.